Math 3, Unit 9, Spring Final Review. So this Unit 9 is on the geometric modeling, okay? We remember that density equals mass divided by volume. So, a 30-gram block. When they are telling you that you have a 30-gram block of wood, what is that telling you? Which piece? Is that the density, the mass, or the volume? Mass. And so it's always a good idea when you have word problems going through and finding the information and like writing what it is, okay? In the shape of a rectangular prism, has dimensions of 12 by 5 by 10. What is the density of the block? When you know the dimensions, that helps you find the what? The volume. So we're going to go ahead and find the volume. So the volume is 12 times 5 times 10, and we multiply that, and that makes how much? 600. We multiplied centimeters times centimeters times centimeters, which makes, very good, centimeters cubed. And so based on the information, we can now find the density, because density equals mass divided by volume. So 30 divided by 600. You could put your units of measurement in here if you want to, or I like to do it separately. So my unit of measurement is like grams divided by centimeters cubed, and in this case, when I reduce it, that's just my unit of measurement. So we reduce, I know zeros cancel out, and 3 goes into 60 how many times? 20 times. So I end up with 1 over 20 grams per centimeters cubed. Questions? Okay. A rock with a mass of 240 grams, and there they specifically told us what it was, has a density of 4 grams per kilometers cubed. Centimeters cubed. Sorry. Okay, what is the volume of the rock? So again, density equals mass divided by volume. So in this case, and I'm just going to take the numbers here for a minute, we would have 4 equals 240 divided by volume. And so we want to solve for the volume. Cross multiply, or if you want to just eliminate the fractions by multiplying each side by v, you're doing the same thing. So we have 4v equals 240. Divide by 4 to both sides, and our volume equals 60. Based on our units of measurement for density, the mass was grams, and the density is grams over centimeters cubed, so therefore volume is what? Centimeters cubed. Any questions? Population density is people divided by the area you're in, or the amount of the population divided by whatever it is. Because sometimes it's volume because you're dealing with water and fish. So it just depends on like where the population is living is what you're dividing by. Does that make sense? Okay. A city has an area of 4 square miles and a population of 280,000. What is the population density of the city? So in this case, all we're doing is taking the population, 280,000, divided by the area, which is, good, 4 square miles. And so we just reduce, 4 goes into 28 how many times? So the answer is 70,000. And then our units of measurement, the population is people, so we can write that as PPL for people, divided by square miles. And so I just write that as miles squared. And that is your population density. An island has a population density of 10 people per square mile, and an area of 1,700 square miles. What is the population of the island? So again, population density equals people divided by area. So we have 10 equals, we don't know how many people are there, so I'm going to put a P, or you could do an X, whatever you want to, divided by our area, which is 1,700. In order to eliminate our fraction here, we would cross multiply, or you can multiply by 1,700 to both sides. Those eliminate. When you multiply that by 10, you end up getting 17,000 equals the people. And so I'm going to write that as 17,000 people. Or okay, any questions? All right. So remember that we have these ratios. We know that height ratio is a one dimension. Perimeter is what? One dimension still. Area is 2 dimensions. Surface area, 2 dimensions, and volume is 3 dimensions. In order to find these ratios, depending on what you're using, you either have like the 1 dimension of the figure or the 2 dimension, which means you would square the 1 dimension, and the 3 dimension means you would cube the 1 dimension. So if we're filling in this chart, the perimeter ratio is still going to be what? Good, 2 to 3. The area though will be 4 to 9, because we will square 2 and square 3. Surface area is also 4 to 9, and then volume is 8 to 27. Okay, in the next column, again, this is a 1 dimension, and so this is also 1 dimension, which is 3 to 5. The 2 dimension will be good, 9 to 25 on both of those, and the 3 dimension volume ratio will be good, 27 to 125. Here they're giving us the 2-dimensional ratio, which means in order to find the 1-dimensional ratio, you'd have to do what? Good. And so the square root of 36 is 6, and the square root of 49 is 7. So 6 to 7 is my 1-dimensional. We already have the 2-dimensional. And then my 3-dimensional will be what? 216 to, good, 343. This last one, they gave us the 3-dimensional, the volume ratio. And so in order to go backwards, we'd have to take the cubed root. So what is the cubed root of 64? 4. And the cubed root of 27 is, good, 3. And then the area ratio is 16 to 9, and same with the surface area. Okay, any questions on the chart? Okay, so the same, you use ratios when we're doing scale factor. Okay, so starting with this first question here, it says the 2 boxes below are similar and both have to be wrapped with decorative paper. If it requires 4 yards squared of paper to cover the large box, so right here I'm just going to put our 4 yards squared. Calculate the amount of paper needed to cover the small box. Okay, so first thing is that they've given us the ratio here, then they've given it to us as a height. Height is what? What dimension? 1 dimension, right? And so right now I'm just going to write here height ratio, which is a 1 dimension, and we have that as 24 to 16. You always want to reduce this if you can, and can we reduce 24 over 16? Okay, what does it end up reducing to be? Good, 3 to 2 is correct. Okay, so that's our height ratio. Now, what they've done is that they've given us surface area. Now, what dimension is surface area? Very good. Surface area is a 2-dimension. Okay? So that means with this ratio, we have to use this in a 2-dimension, which means we're going to have to do what to it? Square it. Okay? And so we square it and we get 9:4. So that will be the ratio we are using to find how much we need for the smaller box. So we would write this as 9/4 equals, now, so the 9/4 is dealing with the large box to the small box. And so if we know 4 yards squared takes to fill or to cover the large box, where is that going to go? The top or the bottom? The top. It's going to match, because the 9 is matching with the large box and the 4 is going with the large box, and we're trying to find the small. And so they match up in the ratios. Does that make sense? Do we have questions? Okay, so now all we do is cross multiply and divide. So 9 times x is 9x, 4 times 4 is 16. We divide both sides by 9, and we get x equals. Can I reduce this fraction? No. So if you left it as 16/9 yards squared, that is fine. Or if you typed it into your calculator and found the decimal, it's about 1.78 yards squared, and both answers are good. If on your final you get a fraction but all the answers are in decimals, all you have to do is change it to a decimal. Also, if you think about it, I always try to make sure, does this answer make sense? If it takes 4 yards squared for the large box, would 1.78 yards squared make sense for the smaller one? Yes. If you got something like 17 over here, would that make sense? No, because it's going to take less wrapping paper for the smaller box. So just make sure that your answers make sense. If they don't make sense, go back and check your work, because maybe you used the wrong ratio. Okay? All right, moving on to the next one. The figure to the right is 2 shampoo bottles that are mathematically similar, and the volume of the smaller bottle is 5 cups. So right here, the volume of the smaller bottle, right here, 5 cups. Find the volume of the larger bottle. So again, right here, they have given us the what? The height. So our height ratio, which is a 1-dimensional ratio, is 18:27. Can I reduce that? Yes. What does it reduce to be? It should end up with 2 to 3. We can divide by 9. So my height ratio is 2 to 3, and that's 1-dimensional. Now we're going to be dealing with volume. Volume is what dimension? 3. So we have to take this value and cube each of them, which will make it what? Good, 8:27. So we use our ratio, 8/27 equals, and where should the 5 go? On the top or the bottom? Top, and it's going with the top because why? Because it goes with the smaller bottle, and so the smaller bottle is 8. You could have written this as 27/8, which is fine, and then you put the 5. You just want to make sure that they match up. Okay, and then this is the one we want to find, the larger bottle. So the larges match up, the smallers match up. Okay, so we cross multiply, we get 8x equals 27 times 5. Very good, 135 is correct. Divide by 8 to both sides. This doesn't reduce, so 135/8 works, or if we change that to a decimal, it'll be 16.875 cups. And again, this is a smaller one, this is a larger one. It looks like it would work. Okay, it makes sense. Any questions? Okay. The cylinders to the right are similar. The surface areas of the cylinders have a ratio of 50 inches squared to 72 inches squared. So that right there, they said the surface area, right? So we know that surface area is what? Two dimension. Is everybody okay with that? And so that is 50 to 75. And we need to reduce that.
72.
Thank you. Okay, 50 to 72. And we need to reduce that. What can that reduce by? I know I can start by reducing by 2, right? So 50 divided by 2 is 25. And 72 divided by 2 is 36. So if I want to find my height ratio, getting back to the one dimension, it would make what? 5 to 6, because we would take the square root. So you're always wanting to get to that one dimension spot to make it go to whatever dimension you want to know. Okay, and so in this case it says, what is the ratio of their volumes? So the volume ratio, we would do what to those numbers? Cube them. So 5 cubed is 125, and 6 cubed is 216, and that's our answer. Any questions? Okay, so now we're moving on to this paper. That's out of order, sorry. Okay. So a projectile is fired vertically upward. So what we're talking about here is we have some object that is going vertically upward. Its height after t seconds is given by this formula. It says, what is the maximum height of the projectile? So the maximum height is up here. What do you think we should do in order to figure out that maximum height? Anybody have an idea? This is also called the what? Vertex. So we want to find the vertex in order to find that maximum height. So we would want to put this in what form? Vertex form. Good. And in order to put something in vertex form, we have to what? We have to use completing the square. Okay. In order to use completing the square, we want to write this in, very good, descending order. H equals negative 8t squared plus 48t. When you're completing the square, you do not want an a value, so what do I do? Factor it out. Okay, so negative 8, and we divide this by negative 8 and this by negative 8, which leaves me with t squared. What is 48 divided by negative 8? Good, negative 6t, and then we do plus blank. If there was a number without a t, remember it goes on the outside of the parenthesis. So right now I am taking negative 8 times the number. So what do I do in order to balance that out? Plus 8 times that same blank. So if I have negative 8 times the number and positive 8 times the number, that will balance out my equation. Okay, what do I do next to complete the square? Good. Negative 6 divided by 2, which is, and negative 3 squared is 9. So my equation is h equals negative 8. What is my square going to be? Good. T minus 3 squared. So remember this part right here factors to be that. And it's always this half number. Negative 3, add to be negative 6, and negative 3 times negative 3 multiplies to be 9. And then what is 8 times 9? 72. Okay, so here's my equation in vertex form, which tells me that my vertex is what? 372. So what is the maximum height of the projectile? 72. And if it doesn't say what kind of units it is, we're just going to go 72 units. It says, at what time does the projectile reach the maximum height? Very good. And that is 3 seconds. And they did tell us seconds in the problem. Any questions there? Okay. Next, it says draw the solid of a revolution that is formed by rotating this quarter circle about the indicated axis. So this is rotating it on the x-axis. Here is your x-axis. So you're taking this and you're rotating it around the x-axis. When you do that, it makes a three-dimensional figure. It's going to keep rotating around the x-axis. And what shape does that end up making? Yeah, like a half sphere or a hemisphere. So what's going to happen when it rotates across the y-axis? So it's taking this and moving it over the y. So the same thing, right? A hemisphere, but it's just going the other direction. It's going around the y-axis. So it's always like taking this piece and moving it over the axis a bunch of times, and when it's doing that, it's making a three-dimensional shape. Okay, any questions? Draw and describe the cross sections formed by the indicated slice of the figure below. Okay, so A, what type of slice do you think that's going to be going through that hemisphere? Very good. It is going to make a circle. Okay, the slice for B that's cutting through this way, what will that make? It's going to make a half circle. So I'm just going to draw it like this. But it's like that piece is going right in there. And then C, where it's kind of at a diagonal that way, do you guys remember what that makes? Very good. An ellipses or an ellipse. It's kind of like tomato, tomato. Or some people call it an oval. But the shape looks like that. Any questions? Okay, last one. Volume of our truncated figure. Okay, so remember with volume, volume is your base area times the height for a prism. And if you have a pyramid, it's 1/3 the base area times the height. Okay? Now, the height on this, they've given us the slant height, but we need the actual height of the figure. Also, they have told us that this piece right here is 12, which means that the whole base, the length of that base is actually what? 24 centimeters. Is everybody good with that? How do I find the height? Pythagorean Theorem. But I'll be using the 12 when I'm finding the Pythagorean Theorem. So remember Pythagorean Theorem, we would have a squared plus b squared equals c squared. So in this case, 12 squared plus b squared equals 15 squared. 12 squared is 144 plus b squared equals 15 squared is 225. We want to get the b by itself. So I'm going to subtract 144 to both sides. B squared equals, when you subtract there, you get 81. And then in order to just get b, I take the square root. And so b equals 9. So that means over here my height is 9. Okay, questions so far on this one? Okay, so in order to find the volume, we need to know the base area. So on this figure, my base area is just going to be what? How do you find the area of a square? Very good. Length times width, or however you want to do that. So my base area is going to be 24 times 24. So make sure you're taking that, the whole side times the whole side. And 24 times 24 equals 576. We good there? This is a prism, so that means it is volume equals, or sorry, a pyramid. Volume equals 1/3 times the base area, which is 576, times my height, which is 9. Okay, and you can use a calculator for this. I noticed that these basically, you can think of them all as being over 1. And so I know that 3 goes into 9 3 times. And so 576 times 3 is 1,728. And I'm dealing with volume, and these units of measurement are centimeters, so that is centimeters cubed. So right now, this is my volume for that large pyramid. Okay, so it asked me to find the volume of the square base pyramid and its truncated form. So now we have to find the volume of this. In order to find the volume of just the truncated part, we need to find the volume of the piece that was taken off. Okay? So we want to find the volume of this piece up here, so we're going to kind of draw a little picture of what it looks like up there. So if I know this piece right here is 6, do you know what the height is over here? Three. How did I get 3? Well, I took the height over here, which is 9, and I subtracted 6, and there is 3 left over. So I know that the piece that was taken off is 3 for the height. Is that okay? Now, we know that this whole base right here was 24. So we want to find the whole base of what the top would be. Is that dealing with 1 dimension or 2 dimensions? If we're just trying to find that length. It's a 1 dimension, right? So I'm going to use my 1-dimensional heights. So I have 9 over 3. You could reduce that if you want to, or you can leave it that way. So 9 over 3 equals, for my 9 height, I know my base was 24. If you use 12, it's okay. You just have to make sure you double it later. And I don't know what the one that matches with the 3 is. So we cross multiply. We have 9x equals, and 24 times 3 is 72. Divide by 9, and I find that x equals 8. So the length of that base part up here is 8. So if I'm finding the base area of the top, it is 8 times 8, which is 64, very good. Now if I'm finding the volume of the piece that was cut off, it is 1/3 times my base area, which is 64, times the height, which is 3. And again, these are all over 1, and so I see that the 3's cancel out, and so the volume of the piece that was cut off is what? 64 centimeters cubed. So how do I find the volume of the truncated part? We just subtract these two values. 1,728 minus 64, because that's the piece that was cut off. And when you subtract there, you end up with 1,664 centimeters cubed for the truncated volume. Okay, any questions?